Alright, today we'll be working on 8.4 part 1 of graphing f of x is equal to a times x minus h to the power of 2 plus k. So to start off with, we'll be working on even and odd functions. So go ahead and look at the core concept first. And this is on page 442. 442. Make sure to write this down, it's very important. So a function y is equal to f of x is even when f of negative x is equal to f of x for each x in the domain of f. The graph of an even function is symmetric about the y-axis. So keyword in here is, or keywords actually, is symmetric around the y-axis. This is going to be really important. So even functions are symmetric about the y-axis. And so for odd functions, a function y equals f of x is odd when f of negative x is equal to negative f of x. For each x in the domain of f, the graph of an odd function is symmetric about the origin. A graph is symmetric about the origin when it looks the same after reflections on the x-axis and then in the y-axis. So the key here is the graph of an odd function is symmetric about the origin. So even is symmetric about the y-axis and odd is symmetric about the origin. Alright, so since this is a little confusing, we're going to start off by trying to look at a graph and figure out whether it represents an even, odd, or neither function. Alright, so keep these definitions in mind. It might help to write them down. So I would highly recommend writing it down before we start this. So pause the video and write it down. So let's look at the first one. Number 14. If we rotate it, if we reflect it on the y-axis, it would look something like that. However, that is not symmetric. It's not symmetric about the y-axis. And it's not symmetric about the origin either. It would have to be right over here if we could possibly make it symmetric. It does not go through the origin. So in this case, this one is neither. It's not symmetric about the y-axis, and it's not symmetric about the origin either. Alright, let's look at the next one. Number 16. So this one, how I would like to imagine it is if you fold this in half right here, in the middle right here, will it look exactly the same? Will the lines overlap? Yes, in this case it does, right by the y-axis. So that means this one would be even, because it can be reflected on the y-axis, not by the origin, however. How about this one? This one would be neither. It does not reflect over the y-axis, and it does not reflect about the origin either. Okay, so now how can we prove whether something is odd, even, or neither mathematically? If we had something like an equation. Okay, so let's go ahead and erase these real quick. Okay, I'm going to erase this. Let's get rid of this too. Let's delete this. Delete that. Alright. And let's erase this right here. Okay, so let's start with this one. So we have f of x is equal to 2x. So now we'll need to go back to this definition once again, the two definitions that we have up here. And before we can begin, I have a couple things I want to mention. A function is even when you evaluate the function at x and at negative x, and the answers, meaning the y values, are still the same. A function is odd when you evaluate the function at x and at negative x, and the answers, the y values, are opposite. And most functions are going to be generally neither even nor odd. Alright, so let's go get started. So what we want to do is, so we have f of x is equal to 2x. we're going to replace the x with negative x. All the x's are going to be replaced with negative x. All right. Once we substitute it, we're going to simplify it. So the left side will stay the same. So 2 times negative x is equal to what? It's equal to negative 2x. And now we're going to substitute f of x for 2x, right? Because notice in the very beginning here, it says that f of x is equal to 2x. So that means we can just substitute this part right here and replace that with x, with f of x. But that means we can't bring the negative though, because the negative is not in the original function right here. So it'll look like this. So negative will have to stay outside, and the 2x is going to be replaced with f of x, right? We're just taking this 2x right here and this 2x right here, right? This 2x is equal to f of x. So that means that this 2x is also equal to f of x. All right, so let's go back to our original one, and notice here that it has a negative here. So what does that even mean? Maybe we can look back at our definition. So it says here that it's even if f of negative x is equal to f of x. Is f of negative x equal to f of x? No, it's equal to negative f of x. Let's look at our second one. It's odd if f of negative x is equal to negative f of x. Yes, it is equal to negative f of x. So that means this one is an odd function. Let me write that a little better. Odd function. So this one's odd because f of x is equal to negative f of x in this case. F of negative x is equal to negative f of x. Okay, so pause this video, look over it one more time, try it by yourself. We're going to move on to the next one now. All right. Let's make this a little bigger here. All right, so our next one we're going to try is this one. So this one's going to be number 5. So we have g of x is equal to x squared minus 2. So once again, we're going to replace all the x's with negative x. And if it helps, make sure to write in a different color. It might help you out a little bit. So remember, replacing the x's with negative x. Minus 2. All right. So negative x squared is going to be what? Is it negative x squared? Not quite. Remember, this 2 applies to this x right here and this negative, which is, we can assume, a negative 1, right? So negative x squared is going to give us positive x squared minus 2. And now we're going to do the same thing that we did last time. We're just going to substitute f of x for x squared minus 2. So, and the reason we can do this over here, actually, let me go back and do this in different colors so it's less bulky. Okay, x squared minus 2. So notice here that this is the same answer as this up here, right? X squared minus 2 is equal to x squared minus 2. So we can just replace this with g of x, right? Because that's the same thing. It says right here that g of x is equal to x squared minus 2. So we can replace this with g of x. And notice here at the top, it says that if you're able to replace f of negative x, or g of negative x in our case, and it equals to g of x, then it's an even function. This is an even function, right? Because we plugged in negative x and we still got g of x out of it, which makes it an even function. All right, let's erase this. All right, let's try another one. Going to try, this one will be number 6. Okay. So we have h of x is equal to 2x squared plus x minus 2. Okay, so we're going to do the same thing again. We're going to replace x with negative x, right? Let's go ahead and replace all the x's. Minus 2. All right, so now let's go ahead and simplify again. Negative x squared, remember the negative is part of the square, so it's inside the parentheses, so that means we're also going to be squaring the negative, which is negative 1. So that's going to give us x squared, and then positive times a negative x is going to be negative x minus 2. And now we're going to look back at our original function, right? 2x squared minus x minus 2. At first glance, it looks like it's the same, right? If we compare these two, we compare this one to this one, it looks very similar, right? But notice here that this one here is negative and this one's positive. What does that mean then? Can it be even or odd then if the answers are not the same or opposite even? Because if it's an even function, it has to be exactly the same. If it's odd, it needs to be opposite. Since it's neither opposite nor same, that means it's neither. So in this case, h negative x is not equal to h of x, which means it can't be either. And we continue this too. H negative x is not equal to negative h of x either. And that's why it's neither even nor odd. Okay. Let's continue on the next one now. Let me see here. Let me copy this here. We're going to need this for our next problem. Okay, so graphing f of x is equal to a times x minus h to the power of 2.